Okay, today we're going to talk about the sense of hearing, about your ear, your inner ear. Your ear actually has three sections to it: external, middle, and inner sections. They deal with hearing and equilibrium. We'll talk about hearing today, and then we'll talk about equilibrium next time. So your outer ear is the ear, the portion that you see. The external ear consists of the auricle, which is basically your ear flap. So the auricle collects the sound, and then it travels down the external medius that we studied when we looked at the skeletal system. And if you look at your auricle, it's kind of neat to see. So if someone has big ears, that's really not a bad thing, because if you were to sit and talk to yourself and you actually brought your ears forward, you all of a sudden you can hear better. Your voice becomes louder. Your ear is a collection for sound. So if your ears are larger, or if they stick out a little bit more, they actually collect sound waves a little bit better. The medius ends at the tympanic membrane, and the tympanic membrane is a scientific term for your eardrum. So this is your eardrum. Your eardrum then vibrates when sound waves hit it, and then those sound waves are going to be passed through to the inner part of your ears. So if I look at the outside, auricle is the outer flap. Here's the tube, the external meatus that goes into your skull, so it travels inside. And then here is your eardrum, which is your tympanic membrane. So this is why when you clean your ears with a Q-tip, you do not want to go in too far, because you actually can contact your eardrum. So middle ear then, the middle ear is going to go on past there. Past the tympanic membrane, I then have a cavity, so that's an open space, air-filled space, and it has your auditory ossicles. Remember, os deals with bones. So your auditory ossicles are the three tiniest bones in your body. They are the malleus, the incus, and the stapes. Or if you've heard hammer, anvil, and stirrup, that's the nicknames that have been given to those three bones. The tympanic membrane, or the eardrum, like I said, will vibrate with sound waves, and that vibration of the eardrum will cause the malleus, the incus, and then the stapes to also vibrate. So these three little bones are right in a row, so when your eardrum vibrates, it's going to cause the malleus to vibrate, which causes the incus to vibrate, and then the stapes. The stapes, being the final little bone, is going to vibrate the fluid that's inside of your ear. And that is at the oval window of the inner ear. So the function of auditory ossicles, they transmit sound waves. They're going to carry them through, they vibrate. And they also amplify, because they are a solid material. They make that sound wave a little bit louder. And here is just a good picture to show these are the tiny bones. So if I put those bones on a penny, you can see how tiny those bones actually are. Auditory tube, eustachian tube, connects your middle ear to your nasopharynx, and that helps maintain air pressure. And this would be why, like when you ride in a plane or you go through mountains and your ears pop, what happens there is your air pressure that is on each side of your eardrum tries to equalize. So that is what causes that popping of your ears. Mucous membrane infections of your throat can travel up to your ear and cause middle ear infections. So this nasopharynx, here again, when you look at your face or your head, all of these tubes your nose is connected to your eyes, is connected to your mouth, and is actually connected to your ears. So if you have a very bad strep throat, that infection can actually crawl up into your ear and cause ear infections if they're not taken care of. The inner ear is the most complex of the three sections. So the inner ear is made up of labyrinth. There was a movie many years ago. Labyrinth kind of means tunnels or canals. So there's a membranous labyrinth inside of osseous. So osseous is a bony, it's also called bony labyrinth, within your temporal bone. Between these two canals, between these two labyrinth, is a fluid, and that fluid is called perilymph. Peri again meaning outside. Endolymph, endo meaning inside. So the endolymph is going to be inside, and then the perilymph is going to be on the outside, and we'll have a diagram coming up to show that pretty soon. The cochlea is the most important part as far as actual hearing. So the cochlea, which kind of looks like a snail shell, houses the organ of hearing, so that's where hearing is actually transmitted or picked up. And then these semicircular canals that are also inside of the cochlea, or beside the cochlea, function in equilibrium and balance, which is also why if you have like a sinus infection, that can get into, up by your ears and can cause like balance issues, and that would deal with your semicircular canal. So we'll talk about the labyrinth first. So this is a cross section. I'm looking at the inside of this. So in the very middle of these canals or tubes, very middle, inside endolymph. That's the very inside. Then I have a membranous, which is a thin layer labyrinth. Then I have my perilymph, which is also a fluid. And then I have the bony part, the hard structure part. So those are the layers that make up the inside of your semicircular canals. And these semicircular canals are the part, they're filled with that fluid, and that's very important for balance and maintaining balance. Over here then is that snail-shaped object I was talking about. This is your cochlea, and we'll look inside this a little bit more. Your cochlea is most important for actual reception of hearing. So within the cochlea, the oval window leads to an upper compartment called the scala vestibuli, and then there's a lower compartment called the scala tympani, and they're going to lead to a round window. So oval windows first, round windows second. The cochlear duct lies between those two, and then there's a membrane that separates it, and then there's a base membrane. Basilar membrane is going to be at the bottom. So here's the diagram that kind of puts it all together. So before we had looked at the inside of the semicircular canal. This is the inside of your cochlea. So here again, we're kind of looking at a transverse picture. So inside of here, I have the cochlear nerve, and this is very important because this is going to pick up your sense of hearing and take it to your brain. So cochlear is part of a nerve that's going to take it to your brain. So if I start in the very middle, organ of Corti is what I would call it, also called the spiral organ, but the organ of Corti is kind of your organ of hearing, and here's your little cells that dictate that. Here is a cochlear duct, and then above that you can see I have the scala vestibule is above that, and the scala tympani is below that. So V on top of T, if you kind of want to remember that. The basilar membrane is at the bottom of where you actually pick up hearing. So base is at the bottom of these cells, at the bottom of the organ of Corti. that actually pick up sound waves. The organ of Corti then has the receptors. They're also a type of hair cell, and those hair cells are on that base membrane. And then these hair cells extend into that fluid of the cochlear duct. And then there's a membrane above the hair cells, the tectorial membrane, and that just touches the tips of the hair cells. So here we're just looking at that center part. If we go back to that other picture, we had the scala vestibule on top, tympani on the bottom. This is that middle section. So this would be like my organ of Corti. Here are your hair cells with a little bit of hair that's on the top. It's going to pick up sensations. This tectorial membrane basically kind of floats right on top of it, and they are attached to your base membrane, and then this is going to be carried away to your cochlear nerve. Vibrations in the fluid cause the hair cells to bend. So these tiny little hair cells, when that fluid moves, obviously these little tiny things are going to kind of flow with the fluid. So that causes bending of the hair cells, and that bending then brings in calcium ions, which is going to help transport things in your nervous system. And this is going to release a neurotransmitter that stimulates sensory neurons. And what happens then, if I have louder sounds, more of these hair cells are going to be stimulated, and more of those hair cells are going to pick that up. So then these little nerve fibers, the yellow nerve fibers on your diagram, carry the impulses to your temporal lobes, the auditory cortex, that's talking about your brain. So in your brain and the temporal lobes, that's where your hearing is actually interpreted. Hearing loss can be conductive, so that can deal with actual damage, kind of like physical damage, or it can be sensorineural, where it could be something with the fibers, those hair cells, something like that. As you get older, those hair cells have adapted so much that they kind of lose their efficiency. And then here is a table that basically shows, starting at the outer ear, I pick up my sound waves, they go to the eardrum, they hit the little bones, the bones vibrate, all the way through to your receptor cells and to your brain. So this table just kind of puts it all together. And that's where we will stop for today.